Alright, this is my lab, lab 1, charge statement. My name is James Park. So the introduction, so the purpose of this lab was to stimulate the charge and how they work with one another by using pieces of tapes that was charged, and to recreate the experiment using glow scripts, and to calculate the number of electrons that was transferred from tape to another. The initial conditions are here. So it's like 2e to the negative 4, 0.2 meters, the width is 0.02 meters, and the area is 0.04 meters squared. And the charge on the tape was 1.07 e to the negative 6, and the charge transfer from one to another was 6.7 times e to the 12th. Alright, and the equation is the key constant that you have to know was Coulomb's law, which is just the physical constant, times the two quarks divided by the distance. The Newton's second law is just mass times acceleration. The knowledge over the interaction between the charges, so like same charges would repel, others would attract, and the Q of electron, which is just 1.6 times 10 to the negative 16. So the first part of the experiment was done to just determine the charge of the tape and how they did work, if they even had a charge in the first place. So what we did was we got two pieces of charged tape, put it next to each other and see what happened, and we also had a negatively charged pen we put on the tape to determine the charge. The expectations was that the two charges would repel each other and the tape would stick to the pen because we hypothesized that the tape was positively charged, and the result was that the tape did repel each other and the pen did stick to the tape, meaning that the tape was positively charged. Alright, so experiment part 2 consisted of a system where we had a tape right here that was taped onto a ruler, a yardstick, and then we had another tape that was under it, so it would create distance using electrical force. The distance was around 2.3 centimeters, and the assumptions were that they had equally balanced equal distribution between like the electrons, and there were point charges. So the length of the tape was 20 centimeters, mass was 2e to the negative 4, distance was 2.3 meters. The gravitational force on the floating tape was just solved by using mass times acceleration, which we know the mass. Acceleration would just be g, so it was just 0.001962 newtons. And the magnitude of electric force on the tape, and since the acceleration is 0 because the tape is like still, it would be equal to the gravitational force, so it's the same number. Alright, so to find the excess electron, since we know the force of gravity and the force of electric force is the same, and we know that electric force is equal to this equation this equation right here, we can just use algebra to get this equation, and just by substituting it in, you can solve for that the electrical charge of just Q is equal to 1.07 e to the negative 6. And you can calculate the electrical loss by just dividing this number by the charge of the electron, which we know is 1.6 e to the negative 19, to get 6.7 e to the 12th. Computational model, we just have like inertial constants, so like this would be K right here. This is just no normal charge, atom's length, and the length, width, and separation that we stated earlier. And this just shows the process that we just did to solve these, but in a computational model. So like divide by 1000 to get the mass, get the gravity, which is equal to the electric force, and then you just do the things that we did here in order to get all the numbers we need. Now, by looking at the results, we see that the mass is the same, but the gravity over here is different. And you can see that this is the top tape, the bottom tape, and it's like going like this. Alright. The assumptions we had to make was that there was no air resistance or friction, and it was a point charge and it had equal distribution. But the errors in the experiment for both parts, but specifically the real part, was that it wasn't actually unequal distribution, it was unequal, and there was loss of charge due to bad handling. Alright, so discussion. So if the electrons had a positive charge and protons had a negative charge, what would happen to the observations? So since the question is basically saying like the charges are inverted, but the way one charge affects another charge is not changed, therefore the effects would be just the same. Alright, and why is it important that the charge tape was handled as well or like as little as possible? It's because if the charge tape, since it has lost electrons, if it touches another electron, it will try to neutralize by like transferring the electron between it. Therefore, if you handled it really badly, they would actually lose charge. Therefore, like you wouldn't be able to do the experiment. Alright, that's my lab. Thank you.